The presentation is about impact properties of PLA material relative to infill density. So the previous study conducted on such specimens was performed on 3 different layer heights. And the results show the variation in the fracture toughness of full specimens, I mean 100% infill. The range is between somewhere around 2 to 2.5 kilojoules per square meter, per meter square. Here are some charts regarding the previous research. We now show the results of the best layer height presented in one Presidio paper. So we'll show 10 different infill groups from 10 to 100% with a 10% increment. So all in all, 10 test groups on a 0.1 millimeter layer height. So the tests were performed on an instrumented pendulum with the hammer having a potential energy of 5 joules, capable of testing polymer materials. Impact speed is 2.9 meters per second and starting angle 150 degrees. All is suggested by an appropriate ISO 179 standard. So the instrument pendulum used here is from an Instron manufacturer. So this was conducted in Timișoara with the cooperation of our Romanian colleagues. And this is how the specimens look. So every test group has 7 specimens. 5 is mandatory by standard, and we add 2 for replacements, but all the results will be shown because of the good repeatability between the specimens. So we used type A notch. This is interesting to emphasize. And the cross-section of this specimen at the notch location is 4 by 8 millimeters. So we have different layer heights and different infill densities. So this is how, from slicer software, the layout of such specimen, this is how they look like, from 100 to 10%. So the infill pattern in these specimens is honeycomb. So 6 angle elements are inside the specimen. We used 2 outlines which envelop this infill. And here are the initial results. So these are load deflection data from 100 up to 10%. So the repeatability is quite good. So these polymer specimens have at least 3 peaks in the load deflection response. And between these specimens, all the peaks resemble. So they all look alike in the higher infill densities. So if we look from 100 down to 10%, this repeatability is sufficient until 50%. With 40% specimens, we have some differences in later peaks. So still the first one looks very similar in all the specimens, but the other peaks have some differences. So another thing to emphasize, all the specimens broke in about 1 millimeter of deflection. There was one test group which could last for 8 millimeters. We'll show the reason later. Here are the energy deflection data. So the results have similar conclusions as in load deflection response. So the plateau, as you can see here, where energy is constant at the change deflection, and all other features from the charts resemble up until 50%. With starting from 40%, these results start to differ, with the 10% having the most difference of them all. Here are the average curves. So this was performed in MATLAB. We averaged the results to place them on one chart and to show you the differences between infill densities. So the higher peak, the higher the infill densities, the higher the peaks are. The same goes with the impact energy deflection chart. So higher energies are, as expected, shown in are present in full infill density specimens, and the response decreases with lower infill density. Here are some. Here are two pictures of the layout showing the cross section, so emphasizing the cross section of the specimen. So you see, still the specimen, even if it has 10% infill, it has these outlines around it, which, well, they actually are the only thing tested on these specimens, and still there is some response in the test. Now the deflection results between these test groups. So the 10% stands out only because the deflection was so high in this in this test group. So PLA is a brittle material. So this is quite so you can see it from 100 to 20%, but because there is far less material in the 10% group, it allowed the specimen to have greater deflections. So still during the test, it could outlast this fantastic 8 millimeters because of this high plasticity. The best results you can see from the lower chart with 20% increment. You see how the deflection rises with lower income. Now the force results also 10% is quite different, so we are neglecting it from further analysis, and the results are can be seen better on the chart, having just these 5 test groups. So from 100 to 20, we see how the impact force is quite smaller with lower infill densities. And impact energy, because the deflection was high, but it is due to error, not due to material properties. 10% had higher impact energy. So during this whole 8 millimeters of movement of the hammer, it detected some energy, and this is due to a flaw. So we are neglecting the 10% result. Also on the smaller chart down, we see that impact energy decreases from 100 to about 30%, and we have some how to call it? There is this phenomenon where this energy recovers from 20%, probably due to the same error which is very visible in the 10% group. And last, the impact strength, actually the only representative results in impact toughness tests. So we see the impact strength results with all of these 10 test groups. And because the impact energy is embedded in the formula for impact strength calculation, we see similar chart down, showing that impact strength decreases with lower infill densities from 100 to about 30%, and there is some recovery with the 10 to 20% specimen. So the suggestion is probably to avoid showing this 20% result, because it is probably due this recovery is due to the same error present in the 10% infill batch. And just to conclude, here are the layouts of all 10 test groups. So the further research should include the impact of these outer layers, because we use the standard specimens. There are only one geometry available, but still, if you test FDM polymers with a standard more dedicated to like molded plastics or some different conventional method, you see here that even though we tested 10%, which you don't expect high results with the 10%, there is still some response because of these outer layers, because as I mentioned, the cross section is 8 by 4 millimeters, and this outer layer is about 1 millimeter thick, around 1 millimeter thick. So it's quite strange to actually state that your 10% infill specimen has around 2.2 kilojoules per meter square, and the highest possible full infill is around 2.5, which is maybe 10-15% greater, just because of this influence of the outer layers. So the further research should include bigger specimens with the same outer layer thickness, just to actually have proper results. So this is all. Thank you for your attention, and I am free to answer your questions.